Okay, let's go on to ellipses. They're going to be at an angle to the axis, or the axis, and it's going to go through both sides, and you're going to form this ellipse. And it's a set of points, the sum of whose distances from two fixed points is a constant. So I discovered I can draw decent ellipses using one of the tools on this iPad, so you get decent pictures. But anyway, the one that you see at the first one, this one right here, all right, it's a horizontal major axis, and it's because it's x minus h quantity squared over a squared, and a is going to be the bigger of the two numbers. Go by the biggest. Y minus k quantity squared over b squared equals 1. Now what do these different measurements mean? I'll tell you in just a minute on another picture. If your major axis is vertical, then the bigger denominator will be underneath the y, which is what you see in that second equation. So you really need to write both of these down and recognize what's the direction of the major axis. Counting to 3. All right, in Zoom, in class, I'm going to show you how the relationship exists for this Pythagorean theorem that's going to be. So the distances A, B, and C are all related. Now what are these distances? A is the distance from here to here. B is the distance from here to here. And then finally, C is the distance from here to here. Now, each of these here to here's is the center to the vertice is the major axis, that's A. The center to the end of the minor axis, that's B. And the center to the focus is C. And again, this relationship is extremely important. You need to know that. Okay, so vertices are the ends of the major axis. Foci always lie on the major axis with the vertices. And the endpoints of the minor axis, they don't really have a special name, except I guess I need to fix spelling axis. My S didn't come out very well. Okay, so endpoint of the minor axis is just called that. Counting to 3. Okay, so we're going to go ahead and graph this one. So the equation is in that form. It's already in graphing form. And I look for the bigger denominator and I say, okay, 169 is the bigger one. So A is equal to 13, and the major axis is horizontal because that's underneath the x, that bigger number. That 169 was underneath the y, that would be the major axis. All right, B is going to end up equal to 12. And C, when you use your Pythagorean theorem relationship, is going to be a 5, because you have 13 squared is equal to 12 squared plus C squared. So you don't really need to do the Pythagorean theorem in that case, because it's a Pythagorean triple. Okay, so those are things that we know. We got the major axis. I did not write the center yet, so I can write the center. It's going to be like with our parabola. It's going to be 3, negative 4. So I made smaller units for this so I could have more length, so to speak, but I need to have, let's see, looks like I need room. So I'm hoping this will work. I don't like that one. Let's try it again. All right, let's plot these points. I think I want a different color. Let's do green. The center's at 3, negative 4. So that point is my center. One, two, three, 4. I went too far again. Okay, it's right here. So if the major axis is horizontal, I've got to go 13 units in either direction. So 13 units in to the right, there's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. go the other way, 13. All right, those are vertices that we're going to identify. So the first vertex, I went from -3 to the left, except I didn't graph my center very well, did I? Crud. Oh, goodness. You know what I'm going to do? No, I better not do that. All right, I have to fix this. My center's at 3, -4, and I pause this for a second. All right, let's start over again here. I'm going to graph this with a different color. I don't like green anymore. So we'll do blue. 3, -4 should be right here. All right, now I need to go 13 in either direction. I hope I have enough room. I don't have enough room. That's just sad, sad, sad. I need to redraw this. One more time. 3, -4. 1, 2, 3. 1, 2, 3, 4. There. 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There's my point. I need to go 13 in the other direction, so that's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Crud. Not too far. I'm having lots of fun here on a Saturday afternoon. I'm supposed to go 12 up. That's why I use the bigger rectangles for this grid. So 12 up is here. I hope and pray that it fits down at the bottom. If it's not, I'm going to say it is. It barely does. Slightly off, but oh well. Tough tiddlywinks. Alright, so the foci are going to be 5 units on the major axis, which we said was horizontal. So I have to go 1, 2, 3, 4, 5. There's a foci. And this was a vertex. This was a vertex. The other foci is going to be right here. I'm going to identify those points in just a second. All right, tell you what, why don't we do it now? The first vertex, if I go 13 to the right from a 3, that means I'm at 16, -4. The second vertex is 13 to the left from a 3, so that means it's a -10, -4. The foci, I went 5 to the right, so that means I'm at 8, -4. And I went 5 to the left, that puts me at -2, -4. So all I have left to do is try to graph this. Okay, let me entertain you then. Yes, yours have to be as beautiful as mine, so I'm losing patience already. So there's our ellipse. Doesn't look like those other wonderful ones that I had over there before, but oh well. Life's tough. Wonder if I could have done that. Let's try it one time, see if I can learn something. I don't want to select, I want to draw. I don't want to select. Alright, this does not work. Alright, so can't freehand that thing. Alright, so we did everything we were supposed to do. Count to 3 and moving on. Yeah, we're supposed to write the equation in graphing form. So let me just go back to black. I'm going to group the x's together. And put the 400 on the other side as a negative 400. Before I can complete the square, I have to factor a 16 out of there. Got to factor a 25 out of there. Okay, so I need to complete the square on the numbers and things that you see here. So I'm going to take somewhere, I think I'll do it down here, negative 10 divided by 2 is a negative 5, square it, and I get a 25. Guess what 16 times 25 is? It's 400. So you probably won't believe me if I just wrote 400, so I'm going to put it this way. Let me get a different color. Should have used a different color to begin with. This 25, when I put it right here, is actually 16 times 25. You cannot forget that. And if I take the negative 8, divide it by negative 2, and I get a negative 4, and I square that, I get a 16. So I'm supposed to put a 16 right here, and then I have 25 times a 16 that I have to add to both sides. It's imperative that you do that properly. So this is 16 times x minus 5, quantity squared, plus 25 times y minus 4 quantity squared is equal to 400, because this 400 adds out with this one. So you're not done yet, because the equation has to be equal to a 1, so you have to divide by 400 everywhere. When it's all said and done, you end up with this equation, which is the equation you're supposed to have. So I probably would ask you, what's the center? 5, 4. And the major axis is horizontal again, because the bigger number is underneath the x. And the x is horizontal. X-axis is horizontal. All right, counting to 3. This one is just write the equation of the ellipse with that center there and vertex and foci. So I think it's imperative that you graph whatever's going on. And if we put things on the graph so we can identify things, here's my center right here. 6, 3, 1, 2, 3. All right, something's wrong here. Did I get a mistake? One mixed up here. All right, I think I got this mixed up. All right, the ellipse has not got a center at 0, 0. That's not possible. So what I think I'll do to fix it, if I want to keep the 0, 0, is I'm going to cause this to be something different here on each of these. So this should be a 3, or excuse me, a 0. This would be a 0, and this would be a 0. So that means when I start plotting points, 1, 2, 3, 4, 5, 6, that's a vertice. 4 is going to be right here, that's a foci. Negative 4 is here. That's another foci. So I know that this graph, I'm just going to draw it with this highlight thing so I don't have to be perfect on it. It's going to go like this. It's going to have a horizontal major axis. So there's things that I know and things that I need to figure out. All right, let's go back to black here. I know that A is 6, and I know that C is a 4. What is B? I need to know what B is, because the equation is going to be x, and since it's a 0, it's 0, 0, so it's going to be x squared, and I'll have y squared, and the bigger number would go here, 6 squared. If you want to put that there, we can. But I need to figure out what b is. Well, that's where the Pythagorean relationship comes into play. So you're going to have 36 minus 16 is equal to b squared. B squared is equal to 20. That's good enough. I'll just write a 20 there. And there's the answer to this question. What is the equation with a center at the origin with that information? All right, counting to 3. All right, so write the equation with a center at 5, 1, vertices at 5, 4, and the end of the minor axis at 3, 1. So let's see what happens with this gem. One, 2, 3, 4, 5. Here's my center. Vertice is going to be at 5, 4. So 1, 2, 3, 4. This point right here is a vertice. Then we have a end of the minor axis is at 3, 1. That does not have a name. But I know that this distance from here to here is 3. So I need to go 3 to the other side, and I know this distance is 2. So I need to go 2 to the other side, and this would be my ellipse. Beautifully drawn, as usual. So what are the things that I know? I know that, I want a different color. I know that A is equal to 3. I know that B is equal to 2. I don't know what C is, but honestly I don't need C to answer this question. And the major axis finally is one that's vertical, so it's going to be, all right, it's going to be X. I need a color here. Let's do it in blue. I would have X minus a 5, quantity squared, plus Y minus a 1, quantity squared. And then I have to figure out where do the numbers go. Well, since it's vertical, that means the bigger number has to go underneath the y. So I would have 3 squared here, and this would be 2 squared. And you could leave it like that if you wanted to, or you could write it x minus 5 squared over 4 plus y minus 1 squared over 9, and there's your equation written this other way. But either one is fine. All right, so there is your equation, and I guess what I would emphasize, people that don't graph it, they mess up. You cannot figure out what the major axis is going to be, and that would be for any of these different conic sections. You need to make a rough sketch so that you can figure out the direction of the major axis, or where the parabola opens up, or later on when we talk about hyperbola, the transverse axis. All right, moving on. There's your knowledge check. I want you to tell me the center from this equation. I want you to tell me A, B, and C. And I want you to tell me the major axis is which kind. Is it horizontal or is it vertical? All right, I'm going to count to 5 and stop the video.